Scientist, Director of Analytics, Environmental Protection Agency, and W. Philip Webster, Chief Computational Information Sciences and Technology, NASA Goddard Space Flight Center. To the stage for a look at how to scale the enterprise to leverage big data for improving the mission. Gentlemen.
Thanks a lot. Okay, so last session before lunch, I believe. We'll get right to some questions. She already did the intros for our panelists, so I'm just going to kick us off with a really dumb question, but I think a question that will help us have a conversational panel. And with that said, I encourage you guys to think of some questions at some point in the next half hour or so, or less. I'll open it up. So if you guys start to look like you have questions and you're inquisitive and you pay attention, like good students, then I will call on you. With that, we're talking about big data analytics, supercomputing, high-performance computing, runs the gamut there. How big is big? Phil, go ahead. Tell us a little bit about what you do.
Hello there. So I run a supercomputing center, and this supercomputing center is weather and climate modeling at Goddard Space Flight Center. I really would prefer to talk today about big data and how you actually can use some of these simulations. And if anybody wants to talk about supercomputing, we can do that at the lunch break. But for big data and climate modeling, big data is bigger than anything that you can handle right now. So we're producing models or have run models that can produce, data sets that are hundreds of terabytes in size, and that's sort of where big is to us right now.
Go along and tell us a little bit what you do in that scope of that question. Go ahead, Jeff.
Sure. My name is Jeff Delaboja-Dare. I'm the NOAA Data Management Architect. And at NOAA, which is the National Oceanic and Atmospheric Administration, we have satellites, ships, buoys, radars, people observing corals with it's using scuba gear, counting fish from commercial fishing vessels. So we have a lot of data in terms of volume. Multiple terabytes per day of observational data, and at least an equivalent amount in numerical model outputs. So let's say tens of terabytes per day total, and then tens of petabytes right now in our archive.
And that's only going to get bigger and bigger, too. We're going to talk a little bit about this. They have 2 new satellite systems that'll be producing several orders of magnitude more data that'll become operational here in the next 6 to 12 months, and then only more and more adding as that goes along. Yep. Robin.
Hey, good morning. My name is Robin Thorntingle. I'm the Chief Data Scientist for EPA. So when people ask me this question of how big is big from a data perspective, I always try to give some pointers, right? And I think that's what I was doing on the napkin. And as an engineer, I love doing this. So if just to put a perspective on what that means is if you take Washington, D.C., and if you fit the football field in Washington, D.C., that's approximately going to be around, I think, 50 times 10 raised to 3 football fields you can fit there, right, in D.C. And if you put a sensor, like a real-time sensor in the middle of one football field and start monitoring the environmental information, you start getting approximately 600 petabytes of data from Washington, D.C. alone. And that's a sensor that is giving me millisecond data. So you see, from an EPA perspective, and if I'm just looking at the application of real-time sensors for environmental monitoring, I'm already telling you that I will have 600 petabytes of data coming from just Washington, D.C. alone. So scale that to the entire United States, scale that to the entire world, right? So just in one sentence or one aspect of EPA's problem, I told you the size of the data that we are going to deal with is astronomical. Then satellite data, that is another aspect. Then we have the regulatory data that is not that big when it compares to petabyte of data coming from these sensors.
And Nick.
Well, I like the challenge that we've always had with data is the 4 V's: volume, velocity, veracity, and variety. And all of these factors are sort of what we contend with. And Pure Storage is actually a very data intensive outfit ourselves. We've got over 7,000 arrays that report over 1 trillion different events every day. I think my data set aggregate at this point for all array telemetry over the past 7 years is now up to 8 petabytes, and it's growing at about a petabyte every 3 months. So these are challenges that we have today. I had similar types of challenges, especially with variety and volume in my in my past. I was the CTO for Army Intel. So it's all manner of different data, geospatial data, text data, sensor data, electromagnetic spectrum data, models and simulation, terrain and weather, the whole 9 yards. We always get down to what kind of questions are we asking? What do we want to know from our data? Do we have that data to provide that? And then do we have the engines necessary to help us get the answers we're looking for to provide timely, relevant, accurate, predictive information so we can make smart decisions? So that, how big is big? Moore's Law, and this is Mr. Webster's comment, is absolutely correct. The data scale is scaling with Moore's Law. We're getting exponentially more data every 18 months. And that's a big problem. Where do you park it? What are you doing with it? How do you process it? And the benefit to this is technologies, I'm speaking on the industry side, technologies are coming along that are actually now allowing us to leverage that data, again, in a relevant, timely, accurate, and predictive fashion.
And one of those technologies is analytics, right? I mean, that's, if there is a one-word answer to do more with less in this administration's push for tech, I would have to say that analytics is one of the key ways in which we would do that, right? We're seeing that a lot in government on the fraud, waste, and abuse side already. I wrote about a couple of use cases. HHS recently saved $1 billion in just going after people who were taking advantage of Medicaid, so Medicaid fraud. That was one example. Postal Service cracked a fraud ring as well that saved another $1 billion just using analytics shop they have within their OIG. Those are a couple of examples. I think what you guys do is extra cool, though, because I'm kind of a science guy. I love to think about the world that way. Robin, I want to start with you on just what you're doing. Your CIO on the panel before, like, name dropped you probably like 6 or 7 times and said you were super cool and super smart. So, and said you were working on a really cool platform, I think, that had generated some 1,000 users, I think, now. It's got some attention internally. So tell us about that.
So I think, thanks to Steve for, putting my name out there. That is always good. So I think what we have done is when I joined the agency almost 2 years ago. So we were trying to understand how can we take the agency from its current state to more of a digital transformation? How do we bring that about, right? And one of the things that I have noticed in my experience so far is digital transformation is easier when you start with visualization, because visualization is something that everybody can understand. Every program office will understand the value of taking their data and visualizing it and just making a decision out of it. So with that in mind, the first thing that I did at the agency was we started deploying a visualization platform. And I think Steve was mentioning, we picked ClickSense as one of the enterprise-wide tools, but that's not only the tools. We have people using Tableau, we have people using D3s, RStudio, so you name it. We have a different set of people who is using different aspects of the visualization tools. But the major one that we picked was ClickSense. And what happened over the course of last 1 year was we did training, we had enough conversation with different part of the agency to understand their problems. And because of the ease in which you can start doing visualization, there was a tremendous interest. And people started using it. And on top of that, there was a couple of major hits where some of the program officers were able to save a lot of money by using visualization because they saw that they were wasting money or they were using multiple contracts to get the same thing. So that helped us to create almost an avalanche effect of people adopting the platform. And I think one thing that we did along with just using the technology is we created a community of practice. So this was not just like an IT department rolling out a technology and telling the entire program office or entire agency that here is a technology, use it. So we created a community of practice, and we have approximately 250 people that is a part of that community that talks about what they do with visualization, what their challenges are, and then from there, that is helping them to understand that they are not isolated. They have a group of people across them who is also trying to solve the same problem. So that's basically the short version of the story.
Do you have any more examples where that technology saved some money or found some you said duplicated contracts was one example. And then on a side note for that, or as an aside from that, you said the community of practice was like 250 people? Yeah. Was that all internal EPA folks?
So internal, so in the sense like if there is contractors, they can be a part of it too. So anybody who is a part of EPA can be a part of the community of practice. Another one that we have done is, and this is mostly on enforcement, we started looking at data from other agencies and we start bringing that in, and then we used cloud computing along with some of the high performance analytics components we had, and we were able to spot some of these things that is like not been seen before. So I think the agency is starting to adopt this, and there is a lot of, I think what I see is more than technology. What I would say is it's not the technology alone. You need to make sure that you are creating a platform for people to talk about their challenges. I talk to them on a day-to-day basis, and I understand what their challenges are in adopting it.
So the people aspect is huge, and I want you to maybe expand a little bit more on that. How do you get those folks to come into your community of practice? How do you get the buy-in at the top levels to do this stuff? Or was it really easy for you? I mean, because we always hear about that people challenge, but maybe it was easy for you. You're a charming guy. I mean, I'm sure you have a way with words. Maybe you just talked everyone into it real smooth like that.
No. So the trick was, when I started, there was a couple of things that I also brought to the agency. Like the concept was, let's go with the concept of a lean startup, right? And then I know that lean startup does not translate one-to-one from the private industry into the federal government. There are challenges. But one of the things that we did there was, look, if we start trying to influence this from a top-level standpoint, I will be sitting still in meetings, trying to understand how this is going to impact the agency. So what I did was, I identified people within the agency who is actually driven to do this work from a staff level, right? I think the idea is usually explained is, if you look at this room, there is probably 2 or 3 people in the room who stood in 2006 to buy the iPhone, right? There is an adoption curve. There is a adoption diffusion curve. If you Google that, you will see that any new technology, there is a set of people who is willing to try it out. So what we did was, we identified people within the agency who is willing to take that first risk, and we started working with them directly. And it's not my credit alone, because I have a good amount of staff who knows the agency and who has been in the agency longer than me. So they told me, look, this person in Region 9, this person in Region 10, this person in this program office, these are good people. They will take the first bait on this one. And so we met with them and we talked to them and tried to understand if they are interested. And then they became that proponent of the technology within their program office.
All right. So Phil, I want to go over to you. We were talking, and you guys have a cool, I wrote down the phrase, climate analytics as a service. I'm sure that many of you are familiar with as a service, almost everything, but I had never heard climate analytics as a service until I met Phil. So I think it's interesting. Give the audience again one more, some of the data that you're talking about goes back decades, right? It's climate data. You're doing some pretty cool stuff with it. Tell us about it.
Okay, well, let me sort of set the context here. One of the challenges that we see coming in the future is, how can you take climate model data for the future and bring that to folks in other disciplines, people that don't understand NetCDF as a data format, all these kinds of things. How can you take climate model data and get it to water resource managers, public health people, engineers that are building bridges, canals, things of that nature? And so we've invented this concept called climate analytics as a service to get by all of the difficulties of understanding the formats and the meanings of the data types. And so in order to do this, we think you need essentially 3 things. The first thing you need is interesting data. And I think that we have that. We run a lot of really large simulations. But the 2 I want to talk about are this reanalysis, which is running a modern climate model starting in 1980. And as you advance it through time, you actually infuse it with observational data, which come from NASA and NOAA satellites and a number of places. So this allows the climate model to be corrected by the data as you move through time. So this is now a data set that a scientist can go in and start to do research within that data set. So that's the first thing, is we have interesting data. Second thing you need to have is a high-performance storage compute fabric so that you can work on this data. Now, as Jim Gray told us a number of years ago, we're getting to the point we can no longer move data to computing. You can no longer move data to computing. You have to put the computing in the data. And so we have built a very large petabyte Hadoop storage cluster, which has, it's in a cluster architecture, which means that you can compute with direct attached disk to the processing capability if you can program to it. Now, we don't believe that Hadoop is necessarily the best structure or the best solution, but it's the one that we're using right now. And if you lay out your data properly in this Hadoop cluster, if you do analysis in time, they are essentially embarrassingly parallel. You can do all of your time steps at one fell swoop through the data, pull the answers back, and then do your analysis in time there. okay? And then the third thing you need is you need the ability to write simple applications to this data. So we have invented something we call canonical operations, which you can make a call. It's an it's an API call directly into the data for basic operations like add, subtract, multiply, maximum, minimum, variance count, and these kinds of things. And you can just send it as the result is a function of time and space, over time and over space. And so a user can use a simple Python call, submit that call to our data, and get an answer back. Or you can stage those that you can now, in essence, program against the data that we have. So you now have access to a very large data set. The work is being done in my computer, not on yours. You're not downloading the data. And it's a simple API so that you can calculate very complex climate activities. And we call that climate analytics as a service. Now, I have an example if you would like for me to go through that.
Please.
So imagine that you are an infectious disease person and you're interested in mosquitoes. And if you can go back to the reanalysis data, and if you know a range of a particular mosquito population, then you can relate the existence of those mosquitoes to these climatic variables. Okay, first, let me give a couple disclaimers. One, I am not an infectious disease person. I have no experience in public health, and this is probably a simple example. But if you can go back in the data that you have and relate the existence of this range of these mosquitoes, now can you use that combination, I'll call it a mosquito index, and project into the future with future-looking climate models and find how will the range of these mosquitoes change over time. And this should be very easily done using this climate analytics as a service idea.
In other words, you'd see where mosquitoes normally have a habitat, the climate situation in those areas, and then you could forecast through time where those areas are going to be, where a mosquito population is going to be high.
If the etymologist,
where should I not buy a house in 20 years or whatever?
If the etymologist can figure out where they are now, they know where they are. If they can relate it to the variables that we can provide to them, then you can project where it may migrate to.
So you mentioned the infectious disease specialist or whatever. There's a lot of potential uses for that kind of data, right? Those kind of simulations could be in high demand. How would I, Joe Scientist, or someone at FEMA or someone like that, could they make use of that data set? Is that something they could do in the near future?
Well, we have gotten it to the point now, we have the APIs, we're using beta tests for a number of organizations around the country. If someone would like to join in that process, we'd be delighted to have them. We have not reached full production capability on this. It is still, in a developmental activity.
Still a fascinating angle. I mean, given where climate science is going and some of the work that you guys do, it could be a hugely beneficial thing for, I feel like, a lot of federal agencies to make use of. Jeff, I want to go over to you. You collect data from satellites to the bottom of the ocean. So on analytics, with analytics in mind, where are you trying to make use of these types of data sets that you're getting in a growing amount of data sets? How are you trying to make sense of it?
Right, and the actual tagline is from the surface of the sun to the bottom of the ocean, because we observe the sun.
Sorry,
and the
Jeff,
solar
didn't do enough
activity.
research before I did this panel this morning. No,
That's all right.
kidding.
Well, because we look for solar flares because they can, cause disruptions on Earth with communications, power grids, and so forth. So, on the one hand, we do a ton of analytics, but on the other hand, we could do more. So our data tend to go directly from the operational observing system into things like our weather models to predict the weather tomorrow, or into our space weather models to predict whether we're going to have a solar flare event hitting us, or to scientists at the agency who are actually working with those specific data sets. So I think we do a really good job with the analytics that are part of our mission, that we're actually supposed to do as an agency. But then the question is, are there more analytics that could be done if only people had better access to the data? And I think this is going to be a big growth area. We've already seen how making weather data public has generated a weather industry. or we saw how GPS data, which is not a NOAA product, but GPS data has now spawned this whole GPS industry. So are there other industries, other lines of business, other value-added products and services that we could create from our data that we're not going to do? It's not part of our mission, but the taxpayers paid for the data. It would be great if people, businesses, whatever, could come and actually use the data. So that's kind of an area we've been thinking of. We've started doing that in a sort of research and development way. We have a CRADA, Cooperative Research and Development Agreement, with 5 cloud providers, Amazon, Google, IBM, Microsoft, and OCC. That's Open Commons Consortium. They're an academic group. And trying to see, okay, if we give you whatever data sets you want, will people come to your cloud platform and do computing on it and find new things? So this is kind of starting. We've been getting this slowly off the ground over the last couple of years and trying to do more.
It's called the Big Data Project, right?
The NOAA Big Data Project, yes. And so about a year ago, we got one big data set out there, the NEXRAD, Next Generation Radar Data. This is all the radars that you see at airports and things like that, these sort of domes that measure rainfall. In fact, when you look at the radar map on TV of where the rain's coming, that's what you're seeing. So it was an actual more raw level of that data was sent there to see if people could do new analytics. And people are starting to do new things. In fact, there's somebody who's studying bird migrations, because it turns out when a flock of bird flies by the radar detects it. And so this person is able to analyze all the data and study bird migrations in the U.S. So, and then you have other entities like, say, for example, insurance industries could be interested in where are the storms, what's the historical kind of thing.
What might be the natural progression from this? It sort of sounds like it's in a pilot stage yet, trying to see what some of the values could be. But where could it go? What could happen here? Could we say NOAA put a whole bunch more data in the cloud and then make it accessible to the general public, or at least academics and stuff like that? How might it work?
Yes, the progression could go like that, exactly. And that's sort of my hope. This is Jeff's opinion, not NOAA decision, but that I feel we should be putting more data onto the cloud. Some of our things we can't do in the cloud, like our numerical weather models, we're probably going to be running those in-house, real-time data processing. But just for public data access and use and kind of commercial data access and use, getting data onto the cloud and then figuring out how to operationalize this, take it beyond an R&D project, but something that's more, we've got a commitment, they've got a commitment, service level agreements to send their data and for them to make certain things available.
So really get it out there and then get out of the way, right? Let some markets maybe emerge around some of these data sets that are currently not made use of in a big way.
Yes, but I would actually add, so what we've done right now is sort of get it out there and get it out of the way. I feel like we have to get it out there and get some more tools out there. So you mentioned visualization tools, you mentioned your analytics as a service. I think we kind of need to seed the cloud with analysis functions that run directly in the cloud natively as efficiently as possible and are kind of tuned to work with the data so that people don't have to build them from scratch if they want to use the cloud. So data plus kind of basic apps, addition, subtraction, visualization stuff, and then people can compose all those and do new stuff with it.
Are you seeing challenges on the workforce side in getting people in here who understand these new emerging technologies better? I know that you guys in government do a lot of customized work, right? NASA, supercomputing, NOAA as well, decades-old systems in some cases that do a lot of the legwork still. Have you addressed that as a workforce issue? I know a lot of federal agencies have a serious lack of talented applicants. They have a lot of job openings for folks like Robin, who are data scientists, that they struggle to fill. How are you guys addressing those challenges early on?
Yes, I'm not in the workforce department, but I do think that on the one hand, we have a lot of very talented people who are data scientists and programmers, and they really understand the data. So I kind of feel like if we were to unleash them on the data, on some cloud apps, for example, we could get really far. The challenge is maybe a little bit more on things like procurement, IT security, permission to run in the cloud, and then understanding that it's not the same thing to run your own room full of Linux servers as it is to program stuff that's going to run in the commercial cloud. And so there, I think we do need different kinds of people, not necessarily traditional sysadmins, but cloud architects and so forth. So,
Nick, that might be a little bit of a weird question for you as in industry, but maybe you can talk a little bit about some of the trends you're seeing around analytics and big data. But you can address the workforce issue if you want.
Well, I was going to. So one of the things that we've seen, particularly in consumer technology, is what used to be tremendously complex systems. You think about all the technology that's in a smartphone or in a laptop right now. All of the how that works is absolutely abstracted away from the user. So one of the big challenges that we've tried to overcome over time is making technology work for people, not the other way around. So one of the things that this kind of simplicity, allowing people to get on the business of doing what they're trying to do, analyze the data, get the answers that they're looking for, gain understanding from that data, gets hindered in a very large way by the complexity of the technology that drives the analysis. So one of the things that we've seen in industry, and particularly true in my company's case at Pure Storage, we pride ourselves on the simplicity of our systems. So it requires fewer hours to operate, fewer hours to work. It requires a lot less space, a lot less cabling, things of that nature, so that we can get on about the business of actually doing the analytics. This reduces the number of people you have are actually turning wrenches on systems and puts those hours and that effort back into what is this data telling me, or what can this data tell me? So it pushes the amount of effort up the stack to actual knowledge work, which I think is incredibly important. It gets us productivity back. It saves us a tremendous amount of resources, but it also gets us to getting value out of the data much more quickly. So that was my contribution on the workforce piece. It allows us to start looking for people who actually don't have a specialty in turning knobs and turning wrenches, as I like to say, but lets us do the valuable part of why we collected the data. The question that you actually asked me was what again?
Just on some of the trends that you were seeing, maybe what's pushing federal agencies to do a lot of this stuff. We have legislation now, modernization legislation that could pass, that sort of thing.
So the old axiom is that if the definition of insanity is doing the same old things and expecting a different result. We've all talked about, we've got new use cases, new demands from our constituents, from our agencies. We've got evolving missions. We have sensors that are capable of collecting a lot more information to finally enable us to get resolution and visibility into what's happening on Earth, what's happening inside a given system, or how do we model or simulate things in a computer that actually happen in three-dimensional space.
In commercial Internet of Things, right?
Absolutely.
That growing market is...
Okay, so we need to build better systems using different technologies to do the same types of things, but enabling us to leverage this vast increase in this ocean of data. And we had another conversation while we were in the green room about data is expanding at the rate of Moore's Law. In the case of storage, which is sort of if there's an IT stool that's got 3 legs of network, compute, and storage is the broken leg. So transmission speeds have gone dramatically upwards. I remember 7 years ago we were excited about having 1 gigabit Ethernet to our desktops. Now I've kind of got 10 gig top-of-rack switches, and that's sort of de rigueur. It's hard to make computers clock faster now, so we simply put more cores on them, but that means we've got massively parallel systems. So we've got things that are capable of doing petaflops of I/O operations per second, and then we've got storage sitting over there at milliseconds of latency and hundreds of IOPS. So how do you change that? Build storage systems that actually can innovate at Moore's Law, that can improve and expand their capability on the same type of production cycle. To do that, you have to get away from areal density-based systems like hard drives and tape, and you actually have to make memory-based storage systems so that they can work well with your memory-based compute systems. And that's what we're seeing the industry doing now. It is a tremendous transformation under the covers, but in a lot of ways, it's a lot like going from cathode ray tubes for televisions to LCD and LED flat panels.
That was before my time. Yeah. No, I'm just kidding. I want to let those guys address the workforce question. Do we have any audience questions? If we do, we have some mics here. Anyone have any questions for these fellows? Negative so far.
Well, let me take a slightly different take, and this is an idea that's only come to me listening to your question. There is a move afoot to hire young, smart people like this guy here and put them in OCIO shops. And there's a long way between me and your equivalent in NASA, you have to go up across the science, over to CIO, and down over here. And so there's a large space between this innovative leadership that's coming here and the practitioners that are here. NASA tends to hire, at least at Goddard, mostly PhD disciplined scientists and engineers. They do not hire a lot of IT people. I've got 3 or 4 positions I'd love to fill, but they won't let me. So the bulk of the IT talent that's coming in is coming in as young people in the contractor workforce, which means that distance. Now, I'm lucky because I have a couple of people that are younger that I can still talk to, and these ideas I've told you about today are not mine. They're clearly theirs. And so how do we infuse a lot of these ideas into middle management, I think, is a bigger problem than hiring young folks into the contractor workforce. So we've got to solve the impediment between you and these 25-year-old kids that are coming into NASA on the contractor workforce.
And NASA's always voted the best place to work, isn't it?
That's a wonderful place to work.
You guys must be doing something right. I mean, how do you get those ideas? Were you just more receptive to a lot of them than other folks were?
One of the neatest things we have is we have a summer intern program at NASA where kids that are in high school, college, and graduate school can come to NASA, which they think is great, and then we pay them $7,000 or $8,000, and they're just astounded that they can do that. And these kids come in, and we say, okay, here's a summer's worth of work for you to do. Well, 10 days later, they're back. What do you want me to do next? And so when you have that level of thinking and that level of capability, and they will push you to do things that you would have never thought of just to keep them busy. And so, and my staff on the contractor side, I think we have 5 or 6 young kids that have come onto the staff as interns.
That's cool.
And these are kids from, NASA does enjoy the reputation of being able to pull in kids from the best universities around. So
when are we going to see people wearing EPA T-shirts and NOAA T-shirts? I see the NASA T-shirts all the time. Y'all got to get out there, get this stuff going.
I think NOAA gets like second best place to work or something.
Is it? I'm not sure I believe you. I'm going to just fact check that later. Robin, though, you are a data scientist. Do you hire them? Did you just get, how did you end up where you are, and what kind of people are you looking to bring into government? And are you seeing the same trend that Phil is, in that a lot of the folks that do this kind of work best are young kids coming in as contractors?
I'm very flattered to hear that people think that I'm coming in from an industry and I can make an impact. But at the end of the day, what I see happening is a couple of things. One, I don't think that we should go back and flat out say that we need people who are young like me. I don't know if I should say that, but anyway, be the people who are going to make the changes, right? Because what I'm seeing at EPA is there are a lot of people who are at the staff level who have the enough skills to do these changes. But what they are struggling with is, for example, one thing, when I joined the agency was in 2010, the previous president issued the executive order on making the agency go cloud first, right? EPA was still trying to understand how they can go to the cloud, because we had a lot of issues with respect to security. We have a lot of issues with respect to application. How do we migrate the applications? But when I joined the agency, I found out that there is a lot of people who are not called as data scientists, but still want to crunch numbers on data, is struggling with analyzing data because the existing capabilities within the agency cannot sustain that. So what we did was, I talked to them. I understood that the major challenge they are having is compute capabilities. And then I went and talked to the security officers and say, hey, what is your problem? They were talking about the confidential information. Guess what? 80 to 90% of our data is open data set. So the whole problem of thinking about an agency going from its data center to cloud has been going backwards because people were worried about the 10% of confidential data. So I told the security officer that I will take the risk. My team will write the ATO. We will go to cloud and we will do a test to find out how we leverage these platforms to do analysis on open data set, right? And I had such a good partnership between my CIO, my CTO, and other part of the agency that we were able to go to the cloud and make the changes. To some extent, Phil was right when we talked about how do we change the management view of some of these things. And one of the things that we are working with the White House previously was on starting to think about where should we place somebody like me in an organization. Is this person need to be at the senior level who should have direct access to the cabinet minister or who should be reporting to the CIO or CTO, right? Because the question is, this role requires people who can have impact at the management level, because you cannot just make a change at the bottom level. You need to always influence the management. Also, being at that level, the benefit is that person has the ability to take the risk. Because some of the things that we are doing at EPA is because I came forward and say that I will put my name there. I don't have any problem having my name on the Washington Post if something goes bad, right? But let's do this, because we have been thinking about this for the past 2 decades, and we are not doing it. It cannot be. This cannot be the way to operate.
Are tools less important than that mindset culturally?
Yeah, I mean, tool-wise, I don't think that technology solution exists already. Look at what is happening in Silicon Valley, right? Google, Facebook, they are getting every penny of your data in every fashion possible. So technology is not the challenge. It's only a matter of getting the government to understand that it's okay to take the risk. If you go and talk to the NIST folks who wrote the cloud FedRAMP certificate, not the FedRAMP certification, the cloud criterias. I talked to them and then when I talked to them directly to find out what does these guidelines mean? And what they told me was those guidelines are there to just give you some kind of a path. That does not mean that you have to tick mark the 10 things that they have written in that, what is it, 50-83? I cannot remember the name of that.
53.
50, right? They told me that. So it's only a matter of people coming to the federal government at the leadership level who is going to willing to take the risk will completely change the government. At least that is what I believe.
Right on. Any further questions here from our audience before we wrap up? Man, you guys, I hate not doing a panel with no questions. Hate it.
They're hungry.
Well, unless there's anything further you guys want to add, I want to say thank you. And if one other thing, you guys are doing stuff that you want more public interaction on. You want maybe agency partners. If people want to get in touch with you and talk a little bit further about, especially Phil and Jeff, on some of the projects that you're doing, can they get in touch with you? What's the best way to go about doing that? Buy you a drink afterwards, or, you know?
That's always a good way.
Okay. Well, get in touch with these guys. They'll be around for a little while. Thanks a lot.